Good morning. Thank you for joining me this morning. I'm Christian Wade. I'm a program manager. I look after enterprise features in Power BI, Azure Analytic Services, and SQL Server Analytic Services, specifically focusing on kind of BI Pro developer features for scalability and manageability and programmability and application lifecycle management and those types of things. So we've got a lot happening in this space right now. So I've been looking forward to this session because I'm hoping to, let you guys see how to use these features. A lot of the demos that I've done recently have basically gone viral, and there's been a lot of hype around some of these features, but not many people have actually seen how to set them up. Right? So that's my primary purpose for today, is to educate you guys on how to set it up. I'm not going to, I may get a little bit fired up, but not as much as I have done at some of the keynotes for some of these features, all right? The primary purpose is to educate you guys. Okay, so you may be aware that the way that Microsoft has positioned our products up until recently is that we've had analysis services for enterprise BI. Analysis services is going to be 20 years old this year. We've been a leader in Gartner's Magic Quadrant for 11 years, and analysis services has been a big factor in that. Analysis services is a very well-established platform for enterprise BI. And what I mean by enterprise BI being the BI that's owned and managed by IT. Right? So it's got to be programmable, scriptable, can be integrated with application lifecycle management processes. And the purpose with enterprise BI is to promote reusability of semantic models in enterprise organizations. So if you've got a large organization reusing a single semantic model, naturally it's going to be bigger, it's going to be more complex. The scalability requirements, the manageability requirements are going to be greater. All right? So that's how we've positioned things till now. And then Power BI is relatively newer than Analytic Services, which, Analytic Services is 20 years old, so that's not saying that much. But so Power BI has really quickly become a real leader in the self-service or modern business intelligence space. And if you've seen the latest Gartner Magic Quadrant, Power BI has been a big factor in our positioning there for the last 3 years or more. Okay, so but we've kind of separated enterprise BI and self-service BI. So what we've seen is that it's not quite as clear-cut as that. The next kind of wave of BI is where the business and IT really work together, and we've seen a lot of customers having to bridge the gap between the two products. So it makes a lot of sense to take the analysis services features and put them into a single all-inclusive platform, being Power BI or Power BI Premium. Right? So that's going to give you the enterprise workloads and the self-service workloads all on a single platform. So you're going to have analysis services, basically analysis services with native integration to the Power BI ecosystem. Right? That's the vision, that's where we're going, and we're making very significant strides in that direction we already have, actually, and we'll be making some very significant strides in that direction over the next 6 months. All right? So at this point, this is where I normally do the Trillion Rows demo. Now, I've got an hour and 15 minutes in total. However, the Trillion Rows demo has already gone viral. Who here has already seen the Trillion Rows demo and would be okay with me focusing on how to set up the BI for big data? So that's a significant number of you. Thank you very much. And now I have to ask the reverse question. Who has not seen the you would have thought these questions would be mutually exclusive, but you'd be surprised. So who has not seen the Trillion Rows demo? Wow. I'm kind of torn here. All right. So there's actually a fairly significant number on both sides. So what I'm going to do, I'm not going to go through the full Trillion Rows demo because I really want to spend as much time as I can on educating you on how to use these features. The full Trillion Rows demo is, you can use this link to see a recording of it, okay? But I will give you a quick version of it, and then we can get stuck into how to set this type of thing up. All right, so this data set is data for a crowdsourced courier service, and the drivers have a smartphone app that emits their locations. Each row in the driver activity table represents an individual location. This location count measure, if I zoom in here, gives us the count of all the rows. It's, you know, everything looks completely normal, and I'm going to casually drag this onto the canvas, and how many rows do you think are in here? Given that I've just called it the Trillion Rows demo, I think I've let the cat out of the bag, but just to put it into context, you know, Azure Analytic Services with the biggest Azure Analytic Services S9 SKU, 400 gigabytes of memory, 25 cores. I did a keynote last year with 10 billion rows, right? This thing is blowing the laws of physics out of the water. We're at 1 trillion rows. This is quarter of a petabyte of data from HDI Spark. This defies the laws of physics, and we're getting instant response times. This should be physically impossible, but lo and behold, we're doing it. And so I'm going to break out distance traveled. I'm getting very fast interactivity, and I'm going to make it a bar chart, break it out by the miles per job, and then I'm going to filter it just by the drivers who left the system, or sorry, left the company. And I'm getting instant response times over quarter of a petabyte of data, right? So the way that we make this happen is that you know, Power BI and Azure Analytic Services, the way that we achieve this blazing fast performance is that we cache data into memory. We compress the data and cache it into memory, which is why the queries that are generated while I'm interacting with visuals on the report the answers get returned really quickly, right? Now, even with our compression ratios, quarter of a petabyte is a lot of data. So what we're actually doing is we're caching the data at the aggregated level, right, which requires a tiny, tiny fraction of the memory requirements and unlocks these massive data sets in a way that was physically impossible before, okay? But your next question might be, well, what if the user drills down to the detail level where there is no cache, right? So what happens then? Well, they don't need to learn Spark SQL or run a different report. What happens is it just submits a direct query to the source. In this case, the source is HDI Spark. It works on all the direct query sources for Power BI, on Databricks, on SQL Data Warehouse, and a ton of others, right? So this is running on up until now, it hasn't submitted a single query to the HDI Spark cluster. I've got a 23-node HDI Spark cluster running here in the background. If I actually drill down all the way to the detail level, you'd see there was a query being submitted to the HDI Spark cluster, right? I'm not going to run that right now in the interest of time. But I will say that, you know, the vast majority of business intelligence queries are aggregated in some form. So you will get very high cache hit ratios, probably 90, 95%. And you will unlock these massive data sets using a tiny fraction of the memory requirements. And then, so then Power BI will catch 90, 95% of the queries because they're going to have some level of aggregation. And the queries that do get through to the source, number one, there are going to be a lot less of them, right? So you're going to protect your concurrency limits in SQL Data Warehouse and these other systems. And the queries that do get through, you can have them, they're going to be more targeted and less aggregated. And you can design the system so that when it gets through to the source system, it's more of a controlled, targeted, non-aggregated type queries, which those source systems tend to deal with very well. So you end up with this balanced architecture where you're using the resources quite efficiently and quite well, and you're using Power BI for what it's really good at, which is these aggregated queries. Okay? All right, I'm going to stop there on the Trillion Row demo, and I'm going to show you how we set this up. So I'm going to start by talking about it conceptually here in the slides. So the way that Azure Analytic Services worked up until the July desktop release was that you would choose for the particular data set whether it was import or direct query, all right? And it was a binary decision, which means that if you choose import, all of the tables have to be import, and if you choose direct query, all of the tables have to be direct query. Right? Most models were, or data sets were import for the fast performance, But for large data sets, you've got a bit of a challenge. You know, you don't need 1 trillion rows to have some kind of for it to become a little bit expensive to manage, right? You need to replicate that data into memory. Sometimes you might not have enough memory, or you might run out of memory, and you want to make efficient usage of memory. There's going to be, you know, your threshold is not likely to be necessarily 1 trillion rows. Currently, Power BI Premium, the largest, the cap on the data set size is 10 gigabytes. We've publicly stated that we're working on lifting that limit. That is one of the key steps towards making Power BI a superset of analysis services to support larger models. So we're planning on lifting that 10 gigabyte limit, and then you'll have closer to Azure Analysis Services model sizes. But even so, you still want to make efficient usage of the memory. Even that may not be enough, or there's a lot of time and effort and money and management spent in replicating that data set into the cache, right? So the larger the data set, the more expensive and challenging it becomes to create an in-memory cache, right? So what composite models allowed us to do, because you know, if you didn't have enough memory, or if this was too much of a challenge, you could switch over to direct query, but then you tended to have slow performance, especially on the large models, right? Because it's submitting, direct query will submit a federated query to the source in the native SQL dialect for every single interaction that the user does on the report, right? So then you had some performance issues with direct query typically. So as of the July release, you can now pick at the table level whether to have the table be direct query or import, right? This opens up lots of scenarios. It kind of gives you the best of both worlds. So where traditionally you had to choose one or the other and the whole model had to be direct query or import, we can now choose at the table level which tables to cache, right? And this alone, even without aggregations, is a very useful feature. You can, for example, just pick a particular table that has near real-time requirements to be direct query so that you don't need to cache it, and the latency is going to be reduced, and all of the other dimension tables for initial report load time for slicers are going to be super fast, right? So you can have a responsive user experience. So this is a summary of the composite models feature. We're going to go into some more detail. But then let's say sales has 10 billion rows. Right? So what we can do is we can create an aggregation of cells. It will just be another table called cells ag in this case. And cells ag is going to have a tiny, far less number of rows than cells. If cells has got 10 billion, cells ag is just the non-empty cross-join of date ID and geography ID, right? Which could just be thousands. Right? So you might actually want a lower level aggregation table than this. You would not typically have a bunch of aggregation tables. If you have that kind of requirement, you'd probably consolidate it all into one lower level aggregation table. But in this particular case, this aggregation table could just be thousands of rows. We've just got the non-empty cross-join of date ID and geography ID, which is going to be relatively tiny. And then we provide some metadata in the data set to inform the engine that queries that come in that request sum of cells. The queries, the users, the consumers know nothing about cells ag. Right? The queries just request sum of cells, and it internally redirects that query. It says, this query happens to be at the right granularity, which is year and city. Those are both attributes in these dimension tables that relate to the cells ag table. And then it internally redirects to the cells ag table, and then it hits the in-memory cache, and it comes back super fast. Right? Pretty straightforward. If you have a bit of a data modeling background, this should seem relatively straightforward to you. Who's ever done aggregations in multidimensional? A few of you. So you will know that aggregations in multidimensional is a black art compared to this. Right? You've got this lattice of all these aggregation intersection points, and you need to spend a lot of time figuring out whether you're heading the aggregation or not. Okay, so this is relatively much simpler, especially if you have a bit of a data modeling background. Right? Then, if we submit another query, this one again is just sum of cells. This is completely abstracted to the user. The user knows nothing about cells ag. The cells ag table is hidden from the user. The user just says, I want sum of cells. but then they try and break it out by customer name, and now internally the engine's going to say, oh, customer name, I can't hit the aggregation table for that because for a particular sales ag record, there'll be one geography, but there could be multiple customers. It wouldn't know which customer to aggregate to. And it's going to say, sorry, I can't hit the aggregation. I'm just going to switch on the fly internally, completely abstracted from the user. It's going to now submit a direct query to the source. OK? Just on the fly. So if in the trillion row demo, I'd actually drilled down all the way down to the detail level, you would have seen it submit a direct query to HDI Spark. All right? Now, one thing that's worth pointing out here is that the date table is white here, representing direct query, whereas it was blue when we were hitting the in-memory cache, right? So the date table flipped back and forth between direct query and import. This is important, an important concept if you're doing dimensional modeling using aggregations. It's much more efficient for date to have this dual role, right, where it can be both direct query and import. Because in the case where we want to submit this down to the source, if date could not act as a direct query table, if you think about it conceptually, it would kind of have to pull all 10 billion rows from the source and then do the join on the Power BI side to join to date. In practice, it's a little bit more efficient than that. We'll talk about it in a minute. But just think about it like that it's not going to be able to push that join and that sum group by operation to the source if date can't act as direct query. Does that make sense? Right? So if date can flip back and forth between direct query and import, then the queries that are going to aggregate cells are going to push that sum group by operation to the source for date, whereas the cells ag one will get the date values from the in-memory cache. Right? Makes sense? So there are actually 3 storage modes that we've introduced with composite models. We've got import, direct query, and a third one called dual. And dual means exactly this, that it can flip back and forth between import and direct query, which is an important consideration from the performance standpoint. Right? OK. So we'll come back to dual. All right? I'm going to gradually get deeper and deeper and deeper. All right? So I'm going to start with what this looks like in Power BI Desktop for dimensional models. All right? I'm going to run through this dimensional models piece, and then we'll pause for a couple of questions. And then I'm going to show you how to do it for big data models. Right? So depending on your definition of big data, a dimensional model could be on top of SQL Data Warehouse, and it could have massive amounts of data as a massively parallel system. So let's see. I'm going to switch over to this desktop file. So here I have this model. So this is the new diagram view where I can see the properties of these tables. And we'll talk more about this a little bit later. But as you can see, currently everything is direct query. Right? Now, this is just AdventureWorks, but imagine if sales had 10 billion rows, right? And it was expensive to cache, right? So what we could do instead is we could create this sales ag table, right? And it's an aggregation of cells. So it's going to be, if you think about it, as the sum of cells grouped by customer ID, date ID, and product subcategory ID. It's going to have many, many less rows in there. That's going to be the non-empty cross-join. It's going to be tiny compared to sales. Right? And the sales ag table is hidden. Right? It's important that it is hidden. All of these aggregation tables should be hidden. Again, this whole concept is abstracted from the consumer. And currently, aggregations is in public preview. We launched it a couple of weeks ago in public preview, so this is like hot off the press. It will soon be supported in the Power BI service, very soon. I'm not going to commit to any hard dates because I've learned from my mistakes in that area. And so it will soon be supported in the Power BI service. At that point, it will still be in public preview until one last feature that we want for aggregations, which is for it to work with row-level security. Currently, in the preview version, you can't have row-level security and aggregations in the same data set. Obviously, we're actively working on that, and hopefully that will be supported soon. At that point, once aggregation works with row-level security, it is almost a certainty that if you're not an admin of the data set, you won't even, the aggregation table won't even be addressable. What do I mean by that? I mean that if you were to access the data set through a role in the service, rather than, if I'm here modeling, I'm effectively an analysis services admin on here. This is running with an analysis services engine in the background, right? So I would be able to run a DAX query against the aggregation table, for example, because I'm admin. But if I then publish this data set to the Power BI service and someone accesses that data set through a role, whether it actually has row-level security or not, that aggregation table won't be addressable. If they run a DAX query, it will act as though it doesn't exist. It will use what we call object-level security, effectively, to hide that aggregation table, okay? So the short version of what I'm saying is always make the aggregation tables hidden, right? We'll keep it at that. All right, so the aggregation table is hidden. And another thing to point out here is that it's just another table. Right? It's just another table in the model. Why did we do it like this? Why is it so different to, for example, aggregations in multidimensional? Why have we made it just another table? The reason it's just another table is, well, actually, there are multiple reasons. One is that this is going to work much better with externally defined aggregations. Right? So I could populate this aggregation table as a table in my data warehouse, right, using ETL processes. And I could use incremental load processes in the ETL for my data warehouse. And I could keep that as a separate table there. I could even, in that case, I could even leave this table as direct query. And I could use column store to optimize it in the data warehouse. And with that alone, even with every single table still being direct query, aggregations makes direct query usable for large models, even without import. So that alone is a game changer. So the fact it's just another table allows it to work with externally defined and externally maintained aggregations, right? It could be an aggregation table in my data warehouse. It could be a table prepared in Spark, all right? Or it could just perform the aggregation on the fly as part of the query behind this table, right? So you've got lots of architectural options there, right? As we know, the architectural questions never have a one-size-fits-all answer. It's always it depends. So it gives you lots of architectural options. Another point about this, it's just another table. So therefore, you can use incremental refresh on it. Right? So incremental refresh is a feature that so incremental refresh only works if it's an import table, obviously, because it's going to incrementally refresh the in-memory cache. Currently, it's still direct query, which is why it's telling me it can't do it. But the point being that, for a really large data set, even your aggregation table could be fairly sizable, and it could be at the point where it would justify incremental refresh. Right? So incremental refresh means that, if you've got a 10-year data set, your initial load will have to load all 10 years, and it will take maybe a couple of hours. But then subsequent refreshes only need to load the data that's changed, which might just be the last 5 days of data, for example. So incremental refresh makes it much more efficient to load these large data sets into memory. Right? So you can use incremental refresh on the aggregation table as well. Why? Because it's just another table. Right? That's why we designed it like this. OK, so this is the aggregation table. And what I want to do now is I want to go ahead and set it to import. I haven't even set up the aggregation mappings yet. Right? We're starting from almost a clean slate. So first thing I want to do is I want to set it to import. I want to set the storage mode. So this is using the composite models feature that lets me pick the storage mode at the table level. So I'm going to go ahead and say I want it to be import. And the first thing that comes up, it says, oh, it's got a few messages up here, and it says, the following tables will need to be set to dual. And in the current build of desktop, this is mandatory. In future versions of desktop, this will be highly advisable. Right? So what does this mean? What it's done is it's traversed the relationships. You can see it's asking for customer date, product subcategory, geography, and product category. And so it's traversed the relationships, and it's figured out which are the tables that are going to benefit by being set to dual so that they can act as both import and direct query, so that if we revert to direct query, they'll be able to act as direct query, whereas if we are getting data from the in-memory cache, they will act as import and we'll have a much more efficient solution, right? So it's quite useful if you have these large data sets. It's not uncommon with Azure Analytic Services to have 50, 100, 150 tables. If you have a 100-table model that's come through as direct query from your data warehouse, and you just want to cache a couple of tables, you can let Power BI Desktop figure out what are the minimum number of related dimension tables that need to be set to dual, right? So that's quite a time saver for these complex models. So these are the tables that it wants to set to dual, this one and date and these ones. So what I'm going to do is, so this new diagram view allows me to set the properties of multiple. I can multi-select objects and set common properties in one go. So I'm going to start with these two alone, and I'm going to set these to dual myself. Right? So it's going to refresh the data in there, and they will act as direct query or import. Now I'm going to come back in here, and I'm going to try and set this to import again. And now it's figured out that, oh, these two don't need to be set to dual. You've just got these three. So we'll go ahead and do that. And this potential security risk, we'll talk about that later, that potentially that relates to privacy levels and query folding in Power Query. All right. So we've now set the storage mode. Right? So at this point, it's an import table. I could go ahead and set incremental refresh if I wanted. But what I'm going to do is I'm going to go straight to the Manage Aggregations dialog. So this is where I set up the aggregation mappings. Right? This is where I tell the engine that queries that reference sum of cells can get redirected to cells ag. Right? So as you can see, it's got all of the columns here in the cells ag table listed, including the foreign keys. So I'm going to start by leaving the foreign keys alone for now. For these dimensional models, it's not mandatory that you set mappings for the foreign keys. We'll come back to that a little bit later. There is an exception to what I just said, but we'll come back to that later. So I'll leave these alone for now. I'm not going to say, for example, order date key is, I could say group by on the foreign key of cells order date key. I'm not going to do that right now, so I'll just remove that. I'm going to come straight down to the actual aggregated values, right? So we've got cells amount sum, and so this is a sum aggregation. So you notice here we've got count, and there's some validation here on data types and various other aggregations, validations I'm not going to talk about right now. But we've got sum, min, max, count, and count of table rows. And this is not a straight one-to-one relationship with the DAX functions. We'll look at that in just a minute, okay? So this is a sum of cells amount. So what this is saying is that this cells amount sum column in the cells ag table has been prepared, and it has the sum of cells amount from the cells table grouped by those three primary keys, right? So we'll go ahead and say this is a sum, and it's a sum of cells amount. Okay? Pretty straightforward. And now let's do the same for the other ones. So this is unit price sum. This is another metric in the cells detail table. Okay? And we'll say this is a sum of cells, but this time it's not cells amount, it's unit price. And this one is a count, not a sum, it's a count of cells unit price. Right? And lastly, we've got this one. So this is a special one, fact internet cells count. This is just the count of all the rows in the cells table. Right? So I don't need to specify a column for this one. I just specify the table. This is the count of all the rows. So the count rows function in DAX is going to leverage that aggregation mapping. So when you were seeing the count on the report and it said 1 trillion rows, it was using the count rows function. I actually showed the count rows function. It was using that count table rows mapping. Okay? So for now, that's all I'm going to do. We'll come back here in a moment. I'll go ahead and apply. And what I'm going to do now is I'm going to actually query this data set, and I'm going to use DAX Studio, because DAX Studio has some really cool new features about when to hit the, to detect whether you're getting cache hits or not. Right? So DAX Studio is an open source tool, and it has lots of great DAX debugging features, and including whether we can hit aggregation. So the first thing I'm going to do is I'm going to run this query. So this query simply asks for the sum of sales grouped by calendar year, which is an attribute in the date dimension, which should be able to hit the cache. So let's find out. There we've got our results, and now I'm going to go over to server timings, and again. Okay, so it's showing that I got a cache hit. I'm not sure why it's not showing the XM SQL. Let me reconnect this. Okay, so it's showing that we had a scan. There's the XM SQL for it. So a scan means that it got the data from the in-memory cache, the in-memory vertipack cache. Right? So instantly, without even looking any further, we already know it hit the cache because the sales table is direct query and the sales ag table is import. Right? So it obviously must have got the data from the sales ag table because it didn't run a direct query on the source. Right? And we've also got this handy aggregate rewrite event. This is an extended event that you can see in Profiler, and it's telling us that we got a match. And it gives us more details here about whether the slice of the actual query and the column mappings that were used. Right? And I've actually got Profiler running as well. And so you have to ignore all the stuff at the top. But you can see here that I ran this same query just now. And we got an aggregate table rewrite with a match found. And this is the Vertipack storage engine query that was submitted. Right? So you can use the Profiler extended events. Right? Okay, so now I'm going to run this query instead, and this is a very similar query. It's also asking for sum of sales, but this time it's grouping by product name. Right? So we got the data back, but this time it's grouping by product name, and if you remember, product is down here, and this cannot hit this is not at the granularity that can hit the sales ag table, right? Because it relates to product subcategory, and there could be many products for a product subcategory. Right? So therefore, instead of getting a scan, we got a SQL, and it's showing us the direct query SQL state or SQL query that was submitted to the source on the fly. Right? And if we go to the rewrite event here, you can see that the attempt failed. Okay? So everything is working as we'd expect here. This is just a straight, simple sum, but this has just demonstrated the concept. All right? And now I'm going to do a different query. This time it's using count rows. As I said, the count table rows is going to be leveraged here. So here we got a scan, so it hit the in-memory cache, and we got an aggregate table rewrite of match found. Right? So count rows leveraged the count table rows. And then here we're going to run a query that is asking for the average. So this is where I mentioned that it's not a one-to-one relationship between the aggregation functions in the aggregations dialog and DAX aggregation functions, because we didn't set up anything for average, and average is not additive, so it would be difficult to prepare an average aggregation column in the aggregation table. But interestingly, if we run this query, we still get an ag hit. We got a scan and a rewrite. Match found, right? So how did this work? So the reason this worked is because we're asking for the average of unit price. And if we come back here, if you remember, unit price was the column that we set up both a sum and a count for. Whoops. A sum and a count for. So internally, the DAX average function is processed by the engine, and the engine is going to internally look at the sum and divide it by the count, right? So internally, it can generate a separate subquery for the sum and the count, and it can still hit the aggregation, right? So that's why average works as well. It's not just sum, min, max, count. There are other DAX functions that can work. And the next one I'm going to run is distinct count. Now, surely distinct count's not going to hit the ag. I mean, let's not get carried away here, right? Okay, it didn't hit the ag, but we can address this, right? Let's talk about this. So it submitted a direct query, and you can see it ran the distinct query here. So what we can do for distinct count is we're asking here for the distinct count of the customer key, right? So back to when I started this on the managed aggregations dialogue, I said that we weren't going to bother with the foreign keys, and we were still getting ag hits. How were we getting ag hits? Because it observed the relationships. The engine was smart enough to say, you know, you haven't specified any group bys on the foreign keys, but I already know I can hit the ag because it's at the granularity based off the relationships that I can just hit the ag, so it just worked. But we also have the option, possibly for verbosity and readability, depending on your own perception of it. We can also say group by cells order date key, then group by cells customer key, and then group by, and then this one's actually not in cells. This is actually, it has to get to product to get to the product subcategory key. So this is, the foreign key is product subcategory key. We could actually do this, right? And then with this, we're telling the engine that, you know, customer key is a group by column. So therefore, we should have all of the values in there, right? We can't group by customer key if it doesn't have all of the values in there. Well, if it's got all of the values in there, it's got all of the distinctness that it needs to run a distinct count query and hit the aggregation table, right? So I'm going to go ahead and save this. Hopefully that makes sense. And now if I run the distinct count, we get a scan, so it got the data from the in-memory cache, from the cells ag table, and we got a match found. So this is useful in this scenario, right? Because a distinct count query, indirect query, could be pretty slow, right? I'm just going to point out that distinct count, this isn't going to be like a silver bullet that solves all distinct count performance issues. There is even if you actually cache the data into memory, there is a distinct count threshold of somewhere between 2 and 5 million distinct values where you'll hit start getting some performance issues. But let's say you've got, let's say even if the cells 10 billion row table were cached into memory and you had, like, let's say 3 million distinct customer key values, you could still get a significant performance improvement because it would get, you might just have 3 or 4 million rows in the ag table, and it would be better than accessing the 10 million row table, even if it was in memory, okay? So there are still some limits with distinct count, but especially in this case where the detail table is direct query, you're going to get a significant performance improvement, okay? As long as you set the group bys on the distinct values and you have the complete list of distinct values in the aggregation table, okay? All right, and then this last query here, this one we would expect to hit the ag because we've already seen that sum of cells and count rows hits the ag, and it does hit the ag. But the reason I'm showing this is that this is a little bit more complex measure, or calculation rather, that we're taking the sum of cells and dividing it by the count of the rows. So this isn't just for simple sum measures, right? This will work for complex measures with sums divided by counts multiplied by ratios that refer to the count of the parent of some other table, of et cetera, et cetera. Because internally, these complex measures conceptually, you can think about it like this. It will generate a logical query plan where it will fold down to the individual sum, min, max, or count, and then it will run that logic to see whether it can hit the ag for each one of those subqueries, right? So it will have done this once for the sum of cells and once for the count rows, and it determined that it could get both of those from the cache, and then it hit the cache. Right? The physical query plan might be a bit different, but logically, that's how you should think about it, right? So it's going to work for complex measures as well, okay? All right, I'm going to thank you very much. I appreciate it. Thank you so much. This is a huge. I mean, I'm not all fired up like I am at some of the keynotes and stuff, but this is literally the biggest game changer in terms of interactive analysis over big data, in my opinion, ever in the history of the world. You know, I mean, this is huge. I mean, this is going to enable interactive analysis over massive data in a way that was impossible before. So this is a real game changer, and I think the fact that I've just demonstrated it all now means that this is way simpler than any of these more advanced performance features that we've ever delivered, like, for example, aggregations in multidimensional. All right, so I'm going to summarize what we just went through. So first thing is about this dual storage mode. I'd just like to summarize this, right? So the way to think about this, the way to conceptualize this is that dual allows Power BI to not have to perform the join on the Power BI side. It can push that join and that group by operation down to the source, which is much more efficient, right? So for example, if we had a model like this with sales 10 billion rows in direct query, and the date table is import, right? In the current build, you can't even have this. It would have to be a many-to-many relationship. But in a not too distant build of Power BI Desktop, you will be able to do this. But if you think about it, how's this going to work? It's not going to be performance optimized, right? Because if you think about it, conceptually, it's going to have to pull all 10 billion rows from the sales table in DQ mode and then do a join in Power BI to get to the date table because all of the date data is in memory, right? Now, in practice, it's a little bit more efficient than that. It's going to generate an in-clause where filter that it's going to push down to the source. And that's the way that Power Query does these cross-source joins. And that's dependent on the privacy levels in Power Query. But even pushing this in-clause where filter, where you list all of the filter members in the query, that's not efficient either, and there's a limit to the number of members you can put in that in-clause where filter. It's much, much, much more efficient to just push the sum group by to the source in 99.9% of the cases. So what you want to do instead is just say date is dual. So you still cache it. If you run a query that only touches the date table, it will be returned from in-memory. If you run a query that aggregates another in-memory fact table by a date attribute, it will also be returned from in-memory. But then if you run a query that requests sum of cells by year, that sum group by operation will be pushed down to the source. All right? So again, just remember, this allows Power BI to avoid having to do the join on the Power BI side, which is much more efficient. Right? And so here are the basic rules. And aggregations requires this to get ag hits. If you've got a relationship that doesn't conform to these rules, you won't be getting aggregation hits. Right? So this is a summary of the rules, assuming it's a single source. Basically, the table on the one side of a one-to-many relationship can always be dual, which is why you tend to get these the dimensions the dimension tables are the dual tables. And that's why with a complex model, that kind of propagation of the dual storage mode that we saw in that dialogue can be super useful. Okay? So that's dual. And to summarize the demo, we set the storage mode at the table level. It propagated dual to the related dimension tables. We went into the manage aggregations dialog. At first, we did not set any of the group by columns. We were still getting ag hits, with the exception of distinct count. We then went back in. We set the group bys on the foreign keys, and then even the distinct count was working. Right? Was getting an ag hit. And we proved that by running DAX queries from DAX Studio, and it was tracing and telling us whether we were getting ag hits or not. Okay? All right. So I'm going to move on in just a moment to how we set this up for big data models, because big data models have, by big data models, I mean, depending on your definition of big data, you know, a data warehouse is big data. But when I say big data, I'm referring to Hadoop-based big data models. So they have slightly different characteristics. So we're going to drill into that. I just want to pause for a moment. Does anyone have any questions that, like, I can maybe take a couple of questions. I do have a lot of content to get through, but I can take a couple of questions on the dimensional modeling if you want, or I can move straight in. You sure? Yes. Yeah. Yes, so if I understand the question, for the in-memory aggregation table, can you set the frequency of the refresh specifically for that table? Absolutely, you can. And actually, another feature which I want to get to is that we're opening up the XMLA endpoints for Power BI Premium, which may mean no sense to many of the people in the room right now. But believe me, this is a massive amount of the functionality from analytic services that is going to come to Power BI by opening up the XMLA endpoint. And the XMLA endpoint is going to give you fine-grained control over how you perform your refreshes, your refreshing partitions and things like that. But even you can refresh only individual tables or individual partitions. And Power BI already has incremental refresh. We'll discuss that in a minute. But the short answer is yes, absolutely you can. And you can do it more effectively using XMLA endpoints, which is coming soon. OK? I'll take one more question, and then we'll move on. Yes? OK, so the question, which I've been asked a few times lately, does this mean that analytic services will be deprecated? Thank you for asking that question. Let's just clear this up now. No, it doesn't. All right, so analytic services has been around 20 years, right? It's been a market dominator in terms of the number of installations. I haven't got any hard numbers to back this up, but I know that in terms of the number of installations, it's been an absolute market dominator for 20 years. And it will likely be around for another 20 years. And the other thing is that the analytic services is what Power BI is built on. Power BI is basically a software as a service abstraction layer on top of analysis services. So even as usage in Power BI and Power BI Premium continues to grow, that's still analysis services ultimately, right? But in terms of the analysis services products themselves, being Azure Analysis Services and SQL Server Analysis Services, no, they won't be going away. Right, so there are many customers that are still using SQL Server Analysis Services, and we will often light up features in Power BI and Azure Analysis Services and SQL Server Analysis Services to ship for the next major SQL Server Analysis Services release. Not all features, like aggregations is only in Power BI, but absolutely not. Analysis Services isn't going away. We just want that, in the next 6 months, we're working actively on bringing the analysis services features to Power BI so that Power BI ultimately becomes a superset of analysis services. So that's going to give you analysis services with native integrations of the Power BI ecosystem. It doesn't mean that if you've got an Azure Analysis Services server that is working quite happily and that you have to migrate it, right? They're going to be supported indefinitely. Azure Analysis Services is actually one of the fastest growing Azure services. There's no way that thing's going away anytime soon, right? It's going to be fully supported, and it's going to be around for a long time. But strategically, we want Power BI to be a superset of analysis services over the long term. Does that answer your question? Thank you for asking that question. I said only one more question, but that one is a natural follow-on. So can we do the migration from analysis services to Power BI Premium? That's exactly what one of our kind of strategic goals is to make it easy for you guys. You've got a lot of processes and integration with DevOps and application lifecycle management, and everything is tied in with SQL Server data tools and your source control systems and things like that. So we want to make it super easy to lift and shift those models straight to Power BI Premium. So when we first introduced Azure Analysis Services, it was like a big deal that you could just take a SQL Server Analysis Services on-prem tabular model. You could just set the deployment server to be the Azure Analysis Services server name, and you just deploy it, and it basically just worked. Right? Azure Active Directory and Windows Active Directory differences aside, it just worked. So we want that same concept. We want to just provide that easy lift and shift to get straight to Power BI Premium. OK, I'll take this last question, and then I do need to move on. Yes?
So is this available in the government cloud as well?
Yeah, everything that I'm showing will be available in the government cloud. Currently, this isn't available in the Power BI service, so technically in no clouds, except our own private ones. But it will be very soon. And there may be a small lag for it to get to the government cloud. I'm not exactly sure, but absolutely, we plan to make these features available. Absolutely. All right, I'm going to go ahead and move on now, back into the deep data modeling world. All right. All right. So big data models. So I'm going to switch back to the trillion row data set. So this is getting data from a 23-node HDI Spark cluster with 1/4 petabyte of data, right? And the model here, oh, thank you very much. That was a test. I'm glad you're awake. All right, so so I'm here in the trillion row demo. And the model here The only table that the users see is this one, the driver activity. This is the one with a trillion rows. And it's direct query, and it's coming from HDI Spark. Right? The aggregation table is in memory, and it's hidden, just like before. But the key difference here is that there isn't a single relationship in this whole model. So with these Hadoop-based big data models, whilst they can deal with like petabytes of data, they tend to not deal with joins across petabyte data sets or petabyte tables very well, right? So what often happens is that this is effectively a fact table with all of the dimension attributes denormalized to it, and it's stored as a file in Azure Data Lake store, right? Or in the data lake. So that's the characteristics here. We don't have this dimensional model where we can rely on the relationships to get from the dimension tables to the fact tables. So what we have to do is we can generate this table. We could generate it in Spark. We could just run a Spark query every night that generates this aggregation table and presents it as a table in Spark. And this table goes down from 1 trillion rows. This particular one goes down to about 1.68 billion rows, which is still quite sizable. Right, when you're in the billions, you're normally talking about 100 of gigabytes or more of memory. Obviously, there's the 10 gigabyte limit right now on Power BI Premium. As I said, we're planning on lifting that. But it's still 1.68 billion rows. But that's actually tiny compared to 1 trillion, right? And how did we get it so small? We got it so small because we removed the high cardinality columns, which are just longitude and latitude. Right? The other columns, the highest cardinality one in here is date. We've got maybe a few hundred drivers and a few hundred counties. But other than that, everything else is just a categorical attribute that's either a Boolean or it's got 5 different, like the buckets for the miles per job just had ranges, right? So the number of distinct values in these columns, the cardinality of these columns is relatively very low. So then when we do a non-empty cross-joint across these columns, we get down significantly from 1 trillion down to 1.68 billion. The high cardinality ones are longitude and latitude, right? So we're removing those. We remove the size. We reduce the size significantly. And then any query that is grouping by any of these dimension attributes is going to hit the cache. Obviously not longitude and latitude. If I'd actually drilled down to see the individual movements for Abigail Johnson, it would have had to run the direct query on Spark, right? And so to set up the mappings here, where before it was absolutely mandatory that it was absolutely optional. Where before in the dimensional model, it was optional for us to set the group bys on the foreign keys. Remember that? We didn't set them, and we're still getting ag hits. Here, we have to set, it's absolutely mandatory to set the group bys on these replicated dimension attributes. For every single one of these, I've got a group by that points it to the detail table being driver activity, and the detail column being the associated column. And then down here, we've got the movement, we've got sum, and then we've got position count is the count of table rows, which gave us that trillion rows number. Okay? So that's it, basically. You have 2 options here. You can either rely on relationships, or you can replicate the dimension attributes into the aggregation table. One is more geared to dimensional models. One is more geared to these Hadoop-based big data models. You can actually mix and match these techniques if you want. So for example, if you've got an aggregation table at the month level, and you want to relate it to the month attribute in your denormalized dates dimension table that's coming from your data warehouse, if you were forced to rely on the relationships, you'd have to normalize that out into 2 separate tables, one at the month granularity and one at the daily granularity, so that you could create that relationship to get to the ag table. In that case, you might just say, you know what, I'm going to just replicate month, quarter, and year in the aggregation table, and I'm going to set up the group by mappings on that, and I'm still going to use relationships for all of the other dimension tables, and it will still work. You can mix and match. If you've got dimension tables that you really don't want to have to normalize a little bit, even though you could do it like with a view if you wanted. But you have the option, all right? So it's pretty flexible in terms of how you do it. Does that make sense? Yep. Okay. Okay, so we're in pretty good time. Run back here. So I'm going to move off from aggregations in a moment, and I'm going to start talking about some of the other really big features that we have coming to Power BI, specifically around bringing the analysis services features to Power BI. So if anyone has any burning questions on aggregations, I could take one or two now, or I can just jump straight in. You sure? One question. Yes, go ahead. Okay. On the Power BI test app? Oh, Power BI desktop. Desktop, thank you. Okay, got it. So the question was, how much memory do we need in Power BI desktop to deal with these large volumes? All right, good question. So I was actually running that locally. It was at between 15 and 20 gigabytes. That's too much to publish to the service, but that will change in the not too distant future, right? So normally it would be the other way around. Normally, you would use the incremental refresh feature to reduce the memory consumption running locally, right? So you could have a 10-year, 10 billion row data set, but then using incremental refresh, you can say, when I'm refreshing in desktop, just load 1 or 10 days of data so that it's nice and small. But then when I publish it to the service, it then invokes the incremental refresh policy, and then it loads all 10 years of data, and then it goes up to, say, 50 gigabytes or something, right? So normally, that's how it would work, and you would use incremental refresh, and you would still be able to set up all of do the modeling, set up the aggregations, bring in all the metadata on a little slice of the data that you're working in desktop. Then when you publish it to the service, you invoke a refresh, then it grows really big, right? And it grows to a point where it's too big to open on your desktop. That's where we're going with this, all right? Okay? Okay, I'll take one more question and then move on. You will be able to use row-level security. So object-level security is kind of implied for the aggregation table, right? So once row-level security works, and we will then have this feature be generally available. At that point, if you're not an admin and you're just accessing it through a role, whether it's got row-level security or object-level security or anything, you won't be able to reference the aggregation table. It will internally use object-level security to restrict that. But you will be able to use row-level security, right? So you'll be able to have row-level security filters propagate down to the aggregation table and the fact table, and there'll be some things that you need to be aware of. What if it can only propagate to one table and not the other? And we'll cover that in a later session once the feature's ready. But the short answer is yes, you'll have full control over the access to these tables. Okay? All right, so I'm going to move on now. So XMLA endpoints. We say XMLA endpoints. Not a lot of people really know what we're talking about. XMLA is an industry standard protocol for that's not just adopted by Microsoft. Microsoft started it, but other vendors use it as well, which is a protocol for client tools primarily for client tools to work with business intelligence data sets, right? And so when we say the XMLA endpoint, what we're talking about is we expose, and by the way, XMLA was introduced in SQL Server 2005, multi-dimensional, right? So when we say XMLA endpoints, what we're talking about is we have a bunch of tools out there, whether it be Power BI Desktop or Excel or all of our competitor products and third-party BI tools, which I don't need to name any of them, but it's fair to say that pretty much every other major BI vendor on the planet supports connectivity to analysis services because it's been a market leader for 20 years, right? So all of these tools, they use this XMLA endpoint, this XMLA protocol to get data from analysis services, right? And the management tools like SQL Server Management Studio and SQL Server Profiler and SQL Server Data Tools even. So SQL Server Data Tools is the model authoring, the modeling tool for Azure Analysis Services. All of these tools use the XMLA endpoint. Now, Power BI is actually running analysis services in the background, right? So it's not a huge stretch for us to just open this XML8 endpoint in Power BI, which means that all of these tools will automatically have access to Power BI, and Power BI just looks like analysis services, and we get the vast majority of analysis services functionality right there in Power BI Premium. It's going to be Premium only initially for technical reasons, right? So opening up this XML endpoint is going to bring the vast majority of analysis services functionality. The open platform connectivity, where you can have a reusable semantic model that's reused throughout your organization in different departments with people using different tools, the manageability, APIs, etc. This is huge in terms of bringing that analysis services functionality to Power BI. So not only open platform connectivity, but as I said, the APIs. So the tabular object model was introduced in SQL Server Analysis Services 2016. It's used often for partition management, for incremental refresh in analysis services. But it can be used by community tools, Tabular Editor, DAX Studio, we saw earlier, BISM Normalizer, I happen to be wearing the T-shirt. All of these community tools will just work with Power BI as well. Vertipack Analyzer, and Analysis Services has a rich history of community tools, and there are some really good ones out there. Right? And then we get all the scripting. So we're going to get the tabular model scripting language, which is what you normally run from SQL Server Management Studio. You can run it in other ways as well. For administrative functions, as well as PowerShell. Azure Analysis Services inherited about 20 PowerShell commandlets from SQL Server Analysis Services. Right? So all of that will be available in the not-too-distant future as well through XMLA endpoints. And I'm going to demo, the demo I'm going to do for XML endpoints is going to touch on incremental refresh. So I'd just like to summarize incremental refresh. So analysis services have supported incremental refresh since day one, right? So, but you have to run the code to manage the partition. So the deal with incremental refresh, you have a 10 billion row, 10-year data set. You want to invoke a refresh on it. You don't want to have to reload all 10 billion rows every time you do a refresh, right? You want to set up incremental refresh so that you only load the last 5 days of data, which is going to cover you for any data changes, for example. Right? So in analysis services, the BI professionals would write potentially thousands of lines of code to manage this, right? And it was a significant management overhead, but it was one of the key strengths of analysis services. Right? And you could use the tabular object model to do that. In Power BI, we already have incremental refresh. We launched it earlier this year. And in Power BI, it surfaced as just this simple dialog where I specify an incremental refresh policy. So I haven't got the time to show you how to set it up in desktop right now, but you can go to this link for a demo of how to set it up. But basically, this dialog pops up, and you define this incremental refresh policy. Right? So this is saying, first time you invoke a refresh in the service, as we discussed earlier, it has no effect on refreshes in desktop. Right? So desktop is only going to have 1 or 10 days of data. But then I define this policy so that when I publish it to the service and I invoke a refresh, the first refresh will take longer because it will load all 10 years of data. Subsequent refreshes will load only the last 5 days of data, for example. Right? Now, in the back end, Power BI is just using a load of tabular object model code to generate a load of partitions, just like it does, just like people have done for many, many years on analysis services. It's just abstracting that and making it easier, right? But because it's an abstraction layer, you don't have that fine-grained control over incremental refresh like you do with analysis services. With analysis services, you can write the partition management code yourself. You can refresh individual partitions, and you have much finer-grained control. Well, with XML endpoints, we're going to be giving that same control in Power BI. Okay? So I'm going to switch over to SQL Server Management Studio. So here I'm connected to Power BI Workspace. Right? This is not a SQL Server Analysis Services server. It's not even an Azure Analysis Services server. I'm connected to a Power BI Workspace. and it's listing all of the data sets in the workspace as though they were analysis services models. Technically, they are analysis services models. Again, Power BI is just a software as a service layer on top of analysis services, right? So this isn't a huge stretch, and this is going to, as I say, bring the vast majority of analysis services functionality to Power BI. So here is, if I've got it here somewhere, here is the same data sets in that workspace, right? So what I'm going to do now is I'm going to look at the partitions. All right, I think I've actually got this open already. So I'm going to look at the partitions for this trip table. So currently, I've just defined the incremental refresh policy in that dialog, and I've uploaded the Power BI desktop file to the service. So it has not invoked the incremental refresh policy yet. So Power BI desktop doesn't know about multiple partitions. It can't deal with multiple partitions. It's only got a single partition, which may be filtered just on 1 or 10 days so that I can fit the data into desktop, right? And that policy is stored in the metadata of the model. In fact, if you look here, I get this just by scripting out the model, saying script as just like any other database. And then here, this is the full metadata of the model that you never had access to before in Power BI, but you did for scripting purposes in analysis services. And here I've got the incremental refresh policy that I defined in that dialog, right? But I haven't invoked a refresh yet, which is why there's only one partition here. So now I'm going to go ahead and invoke the refresh, but instead of doing it through the Power BI service, I'm going to do it from SQL Server Management Studio. And I'll obviously get a timeout. And whilst this is running, I'm going to show you how to generate one of these commands. So we can say process table, and I'd say full, and I'd say script. And I get almost the same command. It's missing these two parameters here because SSMS doesn't know about them yet. But other than that, it's the same command. So this parameter is saying apply the refresh policy. And the other one is overriding the effective date. This is another thing that you can't do today with incremental refresh in Power BI. So for example, the AdventureWorks dataset finishes in 2012. Right? Incremental refresh needs to know what is the current date for it to manage this rolling window, right? And so you can't override the date, but with XML endpoints and tabular model scripting language, you will be able to. So having done that, I can now refresh the partitions. And we can see that it generated a bunch of partitions. Right? So it's got a partition for each of the 5 years. If you remember, the policy over here said, my total data set, my rolling window, so to speak, is 5 years. And so when we start a new year in 2019, it will drop 2011, and it will do all of this for us. And then the closer we get to the current date, the lower the granularity of the partition becomes, up until we get to August 13th, which is what we told it is the current date. Right? And the reason it needs to do this is so that it can maintain that contract to only refresh the last, I think it was 10 days. Right? So to maintain that contract, it needs to have the partitions down at the day level. And as we roll forward, so if I'm going to roll forward 1 day, so as we roll forward, it will generate a new day, and it will opportunistically merge the days into months and months into quarters and quarters into years to get better compression and cleaner dictionaries. So once this is done, we should be able to refresh this and see August 14th. Just give this a second. There's August 14th. And you'll notice also that if I zoom in here, the refresh times for the last 10 partitions or so are newer than the refresh times for the previous one. So it didn't refresh the whole data set. It only refreshed the most recent 10 days based off the policy. Right? So this gives you fine-grained control. Thank you very much. Thank you very much. So this really opens up the fine-grained control that you need to manage these enterprise-scale models. And it's, as IT, you have this fine-grained control. Right? And another thing you can do, which you can't currently do with incremental refresh, is you can refresh a historical partition. Currently, if you want to refresh a historical partition with incremental refresh, you need to refresh the whole thing. Whereas now I can say, oh, well, some data for 2012, for example, got reloaded. They did a merge of the company, and we need to account for some other, I don't know, whatever. So we want to refresh a historical partition that is it's older than the 10-day incremental range, but we still want to refresh it. So then we can say, go ahead and refresh only 2012. Obviously, I would set it to full, but in the interest of time, I just want to keep it quick, and I'll leave it automatic. So I can have that fine-grained control to refresh historical partitions as well. All right? So that's incremental refresh, SQL Server Management Studio, XMLA endpoints. This is really the tip of the iceberg in terms of what XMLA endpoints will bring to Power BI. You know, analysis services, as I said, has been a market dominator for many, many years, primarily because it works very well for these IT-owned enterprise models. Well, we're now bringing Enterprise BI to Power BI. We're going to have a single, all-inclusive platform that does it all. One place to have all of your business intelligence artifacts, right? And you don't need to bridge the gap between the two products. Now, the last thing I'm going to show you really quickly is, I've still got 4 minutes, so I'm going to show you really quickly, and hopefully we'll have a couple of minutes for questions at the end, is application lifecycle management. All right, so with analysis services, you author your models in SQL Server Data Tools, which is running in Visual Studio. And that alone means that you have integration with source control. You can roll back to previous versions. And you can run automated builds that is going to get the latest version of the model metadata from your source control repository and generate automated builds, and it's going to use things like the Analysis Services Deployment Wizard to, in an automated fashion, deploy new versions of those data sets. Well, with XML endpoints, the first version of XML endpoints will have a couple of limitations. It will work with Management Studio. It will have the open platform connectivity. You'll have the programmability. The limitations for the first instance of the first release of XML endpoints is that roles and data sets won't work because there's some extra metadata in Power BI that we still need to update for roles and data sources. Roles and data sources. Roles and data sources, you just can't create or update them in the very first click stop, which will be in public preview. By the time we get to generally available, you'll be able to create roles and data sources. Another thing that won't work in the first release is SQL Server Data Tools, but we plan to make SQL Server Data Tools work with Power BI Premium as well. And at that point, you will get the full traditional application lifecycle management workflows that I just described. And additionally, we would like to make it easier to deploy changes across environments. You know, if you have a bunch of changes in your development environment, you've got a team of developers, you then need to get a bug fix to production really quickly, it's a lot of hassle to make sure that your development environment is up to scratch. And it's not very agile. You can't just script out the measure definition that you need and push it through, right? So there are approaches you can take. You can do branch management and branch merging. And to do that, you could use the BISM normalizer tool for branch merging. But we want to make it easier. You may not have the branch merging organizational capability, right? We want to give you, the schema diff type functionality across your models, so you can have a development, test, and production workspaces in Power BI. And we want to expand this to all Power BI artifacts, but the first version will be just for data sets. Right? So you can have this deployment configuration that stores the source and target workspace and data set. You perform this schema diff, right? And you can pick and choose individual items to deploy across environments or not. Right? So in this case, I'm going to hide skip objects so that I just focus on the differences. This has got about 100 tables in. I'm just focusing on the differences between the two versions of the data set. And I'm going to pick and choose individual items to skip. And I can see actually here, this table, it has a bunch of partitions in the target. So these could be incremental refresh generated partitions. And I just want to deploy a new measure. I don't want to have to reload all my data, right? So I can just say, don't touch that table. Leave it alone, right? In fact, don't touch a few of these. I can just pick and choose what I want to deploy. And then I perform this validation. And this is going to do a dependency analysis to make sure that I don't compromise the integrity of the target data set. It's going to say, you can't delete these two M parameters because there are tables that depend on them, for example. And having done that, I can now generate a tabular model scripting language script, or I can go ahead and just update the target, and based off the options, it may perform processing, etc. And now I can refresh the comparison, and I've just pushed through the objects in a safe way to the next environment. Okay? So this gives you kind of agile application lifecycle management. Right? So this is another open source tool. Yes, go ahead. Not in the current release. Not in the current release. So yeah. So this gives you merging. This gives you merging of branches. This the BISM normalizer analysis services version of this tool gives you merging of branches, which is the only option that you have, right? But it doesn't do three-way merging at this time. Okay. And I'll take one more question. No? Okay. So I didn't have the time to show you real quickly that we do have a new diagram coming that scales to hundreds of tables, breaks out the tables into separate subject areas, and I can set. I did show you that I could multi-select objects and set common properties like storage mode. So we have a ton of new features coming for enterprise large complex models. Thank you very much. Fill out the evaluations. Here's some session resources. And I appreciate it if you fill out the evaluations and go out there and blow your users' minds with massive data sets. Thank you very much.